yesterday we have finished solutions chapter. Now today we are going to start with electrochemistry. Now let us see the important sections of electrochemistry. Beta, there are three sections in this chapter. First is galvanic cell, second is electrolysis, and third is conductance. So let us start with electrolysis first. So chapter for today, it is electrochemistry. Electrolysis. Beta, decomposition of an electrolyte on passage of electricity through its molten or aqueous solution is called as electrolysis. All of us know this. Now, in this section we have two parts. First is qualitative aspect. And second one is quantitative aspect. In qualitative aspect, we will determine the type of product formed in electrolysis. That means what kind of products are formed. Now in quantitative aspect, we will determine how much they are formed. So first of all, start with qualitative aspect. Beta, whenever there is competition between two or more ions to get discharge at an electrode, then the ion having lesser discharge potential will be discharged first. So in a competition between two or more ions to get discharge at an electrode, the ion having lesser discharge potential will be discharged preferentially. This is preferential theory of discharge. Now let us write down the preferential order of discharge at cathode. Preferential order of discharge at cathode. It is, you may say, it is K positive, Ca2 positive, then Na positive, then Mg2 positive, Al3, then water, then Zn2 plus, Fe2 plus, H plus, Cu2 plus, Ag plus. That means if there is competition between these ions to get discharge at an electrode, then among these Ag plus will be discharged in preference to other. Beta, this is using platinum electrode. You can say in terms of discharge potential, among given ions discharge potential of Ag plus is least. Its discharge potential is least. You may say this, or you may say its E0 Rp is maximum. Its E0 Rp is maximum here. Among these ions, we can say like its E0 Rp is 0.80. Now, say for example, E naught Rp of Cu2 plus is plus 0.34 volt. Is it clear? The one having more E naught Rp is supposed to get reduced in preference to others if concentrations are 1n. Now this is the order. We have taken it from electrochemical series. You have to learn this order. Now what is preferential order of discharge? Preferential order of discharge at anode. Beta, preferential order of discharge at anode is, you may say sulfate, then comes nitrate, then comes OH negative, then comes Cl negative, then water, then Br, and so on. Is it clear? So this is preferential order of discharge at anode. Now let us see some examples. Suppose we have copper sulfate using platinum electrode. Beta, at cathode we can say, first of all let us see what are ions present here. At cathode we can say there is competition between Cu2 plus, H plus and water. There is competition between these three to get reduced. Now in a competition between these three to get reduced, you can see Cu2 plus will be reduced in preference to H plus and water. Is it clear? Now therefore we can say it will be reduced preferentially. Now let us see at anode. Beta, at anode there is competition between sulfate, OH minus and water. There is competition between sulfate, OH minus and water. Remember, in electrolytic cell cathode is negative, anode is positive. At cathode reduction takes place, at anode oxidation takes place. Now we can say at anode here, in a competition between these three, water will get oxidized preferentially. So we can say 2H2O converts to O2 plus 4H plus 4 electron. Is it clear? Now you see H plus is formed around anode. Since H plus is formed around anode, we can say the solution becomes acidic around anode. Solution becomes acidic around anode. Is it clear? Now one more thing. Beta, since Cu2 plus are reduced, therefore their molarity is decreased in the solution. Molarity of Cu2 plus in the solution is decreased. So what are product at cathode and anode? Copper at cathode, O2 at anode. Is it clear? Now let us come to another point. What is next point? Copper sulfate using copper electrode. Copper sulfate using copper electrode. Now at cathode competition is same as before. It is between Cu2 plus, H plus and water. In this competition we can say Cu2 plus is reduced at cathode. Now at anode. Beta, at anode we can say now copper will also enter in a competition. Why? Because beta earlier platinum was inert electrode, non-attackable electrode. It was not participating in any competition. But copper is not so. Copper is attackable electrode. It will participate. Let us see their E naught OP. Beta for copper E naught OP is, its E naught is minus 0.34 volt. Oxidation potential of copper is minus 0.34 volt. We can say for sulfate, its E naught is, this is minus 1.96 volt, minus 1.96 volt. Now for water, E naught is minus 1.23 volt. These values I have taken from electrochemical series. Now, the one having maximum E naught OP among them will get oxidized in preference to other. You can see oxidation potential of copper is maximum among all these. So copper will be oxidized preferentially. So we can say at anode, what is the reaction here? Cu solid converts to Cu2 plus 2 electron. Now you notice that Cu2 plus ions are reduced and copper from anode is also dissolving as Cu2 plus ion. So can you see here? Can you see here? Cu2 plus ion are going out of the solution and they are coming in the solution also. From anode they are coming in the solution and at cathode they are going to cathode. That means concentration of Cu2 plus will not change in the solution. Here concentration of Cu2 plus is not changed. Why? Because number of moles of Cu2 plus ion reduced are same as moles of Cu2 plus ion formed. Now let us see one more example. What is that example? Example is electrolysis of aqueous NaCl. Aqueous NaCl. Beta, we can say here we have, this is using platinum electrode. Is it clear? Now water is practically unionized. At cathode, we are having competition between Na plus H plus in water. If you look at the series that we have written, then we can say H plus is supposed to get reduced in preference to other two. Why? Because its E naught Rp is 0.00 volt, while its E naught Rp is minus 0.84 volt. Its E naught Rp is minus 2.71 volt. That means E naught Rp is maximum for H plus. So H plus is supposed to get reduced preferentially. But due to very low concentration of H positive ion, we will say H positive ion will not be reduced. So now it is turned for H2O. Beta, its concentration is very low. So H positive will not be reduced. Who will get reduced? Water. So at cathode we will have this reaction. Now let us see at anode. Beta, at anode we are having a competition between these three, Cl minus OH minus water. Now in this competition H2O is supposed to get oxidized preferentially, but instead of H2O it is Cl minus who gets oxidized preferentially. Cl minus gets oxidized preferentially. Now why is it so? We were expecting H2O to get oxidized and it is Cl negative which is going oxidized. Beta, it is due to over voltage. Due to over voltage. Due to over voltage. Over voltage. What is over voltage? Sometimes the actual potential at which a substance is discharged is slightly more than the theoretical potential at which it is expected to discharge. Why is it so? Why sometimes it is so? Beta, it is sometimes due to slow rate of reaction. Because we know that for slow reactions activation energy is high. Oxidation of water is a slow reaction, therefore its activation energy is high, therefore it needs slightly more potential than the theoretical potential to get oxidized. This difference between the actual potential at which a substance is discharged and the theoretical potential at which it was expected to discharge is called as over voltage. Difference between the actual potential at which it is discharged and the theoretical potential at which it is expected to get discharged is called as over voltage. So here what are the product? Cl2 at anode and H2 at cathode. Beta, all of you remember, solution around cathode becomes basic. Solution around cathode becomes basic. Is it clear? Now let us see one more example. What is that example? One more example. H2SO4 using platinum electrode. H2SO4 using platinum electrode. Beta, H2SO4 ionizes like this. Now HSO4 minus will further ionize to form. Is it clear? So at cathode either H plus may be reduced or we may say water may be reduced. Water may be reduced. Beta, if it is dilute, then concentration of H positive is small, and if concentration of H positive is small, in that case instead of H positive H2O get reduced. We may say this. Now at anode there is competition between sulfate, OH minus and water. From where OH minus came from? OH minus came from water. Now in their competition we will say H2O will get oxidized preferentially. H2O will get oxidized preferentially. Now when we add these two reactions, then the net reaction will come out to be 2H2O converts to 2H2 plus O2. This is the net reaction. All of you should notice that molar ratio of H2 is 2:1. Molar ratio of H2 is 2:1. Now if we have cold 50% concentrated H2SO4 using high current density, we are electrolyzing concentrated H2SO4 using high current density. Beta, in concentrated H2SO4 most of the sulfate ion remain protonated. That means as HSO4 minus. So in very concentrated H2SO4, we may assume that most of the sulfate ion remain protonated, that is as HSO4 minus. That means we can say second ionization is negligible. Now at cathode H positive may get reduced, and at anode HSO4 minus. Now why HSO4 minus is getting oxidized? Because its concentration is very high. Now a question arises, is it possible that changing the concentration may change the we can say order of discharge? Yes, beta, according to Nernst equation, on changing the concentration, ERP or EOP changes. If ERP or EOP changes, then we can say this may affect the order of discharge also. So we may say at anode HSO4 minus gets oxidized to form H2S2O8 solid plus 2 electron. Is it clear? This is Marshall's acid. Beta, in concentrated H2SO4, most of the sulfate ion remain protonated, that means as HSO4 minus, and concentration of HSO4 minus is very high now, therefore it will get oxidized. So what are product here? H2 and H2S2O8. Beta, these are some cases which are, you can say, difficult to predict or which are important from examination point of view. I have discussed them on board. For other simple cases, you may see the preferential order of discharge. That may easily bring out the answer. Now let us come to quantitative aspect. Beta, in quantitative aspect we have Faraday's law of electrolysis. Now what is Faraday's first law? The amount of substance deposited or liberated at an electrode is directly proportional to quantity of electricity passed through the solution. That means W is proportional to IT. Amount of substance deposited or liberated at an electrode is directly proportional to quantity of electricity passed through the solution. Now on removing this proportionality sign, we will get Z. What is Z here? It is electrochemical equivalent. Z is electrochemical equivalent. Beta, you may calculate electrochemical equivalent by using this formula. What is F? F is Faraday's constant. 96500 approximately coulomb per mole. 1 Faraday is the charge carried by 1 mole of electron. Is it clear, beta? Now this is first law of electrolysis. Second one. According to Faraday's second law of electrolysis, when same quantity of electricity is passed through different electrolyte, then amount of substance deposited or liberated is directly proportional to its equivalent mass. Let me tell you. Suppose we have silver nitrate. And we have here copper sulfate. Here we have copper sulfate. The two are connected in series. So when the same quantity of electricity is passed through these electrolyte, then amount of substance deposited is proportional to its equivalent mass. That means mass of silver deposited is proportional to equivalent mass of silver, and mass of copper deposited is proportional to equivalent mass of copper. When will this happen? So we can say when same quantity of electricity is passed. Electricity is passed. Is it clear? On dividing the two, can we say we will get equation of this type? Can we say we get equation of this type? Now, can we write this equation as mass of silver upon equivalent mass of silver, and this is mass of copper upon equivalent mass of copper? Can you see this is gram equivalent of silver and this is gram equivalent of copper. So what are we trying to say? We are trying to say that when same quantity of electricity is passed through different electrolyte, then gram equivalent of substance deposited is same. This is the point. So let us combine these two laws. First was W proportional to IT, second was W proportional to E. Therefore, combining these two, we will get W proportional to EIT. W is equal to EIT upon F. Now, we can say it is MIT upon N factor into F. Now, we can say W by M, that means mole, is equal to IT upon N factor into F. Is it clear? Now, if current efficiency is not 100%, beta, if current efficiency is not 100%, if current efficiency is not 100%, in that case, we have to write formula as this one. What is eta? Eta is current efficiency. Current efficiency. Is it clear? So beta, now let us do some numericals on this topic. All of you note it down. Till then, let me check your doubts. Now let us try to attempt questions on this topic. Question 1. Suppose we have 3 electrolytic cells connected in series. First one contains silver nitrate, second one contains copper sulfate, third one contains AlCl3, molten. These are connected in series. 3 Faraday of charge is passed through all of them. Through all. 3 Faraday of charge is passed through all. Now, you have to find out ratio of number of moles number of moles of silver, copper and Al deposited. Ratio of number of moles of silver, copper and Al deposited. You have to find out this. How can we do this? Beta, first of all check that the metals being asked in the question whether they will reduce or not. Like if we have taken aqueous AlCl3, then in that case in a competition between H2O and Al3 plus, we will say H2O will be reduced and Al3 plus ion will not be reduced. Therefore in such case we have to write 0 corresponding to Al. Now since here we have taken molten AlCl3, therefore Al plus 3 will be reduced. Now since same quantity of electricity is passed, therefore gram equivalent of all is same. Let it be A. Gram equivalent of metals deposited is same. We can say according to second law of electrolysis. Now we have to find out ratio of mole. Beta, moles is, we can say gram equivalent is moles into n factor. So we can say mole is gram equivalent upon n factor. So what is gram equivalent? A upon n factor of silver is 1. What is gram equivalent of copper? A upon 2. N factor of copper is 2. What is gram equivalent of Al? A by 3. N factor of Al is 3. Mole upon n factor, mole upon n factor, mole upon n factor. Its n factor is 1, its n factor is 2, its n factor is 3. We can simplify this and we will get here 6:3:2. Is that clear? Now let us come to another question. 0.5 Faraday of electricity is sufficient to deposit all Cu2 plus ion present in 500 ml of CuSO4. Find molarity of Cu2 plus ion. Find molarity of Cu2 plus ion in the beginning. Beta, on passage of 0.5 Faraday of electricity through 500 ml of copper sulfate solution, all its Cu2 plus ions are reduced. Therefore, you have to find out what was molarity of Cu2 plus ion. How can we do this question? Beta, this is the reaction being asked. Now, I have said 1 Faraday is charge carried by 1 mole of electron. Here we have 2 mole of electron. That means 2 Faraday. 2 Faraday reduces 1 mole Cu2 plus. According to equation, 2 Faraday is reducing 1 mole of Cu2 plus. Therefore, 0.5 Faraday will reduce 1 divided by 2 into 0.5 mole Cu2 plus. Is it clear, beta? Therefore, we can say it is 0.25 mole Cu2 plus. Is it clear? So that means to say the number of mole of Cu2 plus ion present in the solution are only 0.25. Therefore, what was their molarity? Molarity of Cu2 plus ion is 0.25. That means mole divided by volume in liter. And what is volume in liter? 0.5 liter. Is it clear? This comes out to be 0.5 N. Is it clear to all of you? Now there is one more question. We have 0.5 liter of 1 m NaCl. 5 ampere of current is passed for 965 seconds. Now 965 seconds. You have to find out pH of solution after electrolysis. pH of solution after electrolysis. So let us erase this side, this portion. Beta, we have seen that on electrolysis of aqueous NaCl, solution becomes basic due to OH negative ions. At cathode, 2H2O plus 2 electron converts to H2 plus 2 OH minus. Is it clear? Beta? Now we have to find out what is moles of OH negative form. What is moles of OH negative form? Beta, moles of OH negative form are equal to IT upon N factor into F. Is it clear? Beta, I is given to us how much? 5 ampere. T is 965 second. N factor of OH negative is 1. N factor of an ion is equal to charge on the ion. Now F is 96500. It is 5 by 100. Is it clear, beta? Moles of OH negative. Therefore molarity of OH negative is moles upon volume in liter. Moles upon volume in liter. Volume is 0.5. So we can say this comes out to be 0.1. If molarity of OH negative is 0.1, then we can say POH is 1, then we can say pH is 13. Is it clear, beta? Is it clear? Now let us come to another question. Another question is what is mass of silver deposited by that quantity of current which displaced 5.6 liter of H2 at STP. Beta, from question it is clear that the quantity of electricity required to liberate H2 is same as quantity of electricity required to deposit silver. That means the gram equivalent of the two are supposed to be same according to Faraday's second law. So we can say gram equivalent of silver, this is equal to gram equivalent of H2. Is it clear, beta? Now what is gram equivalent of silver? It is mass upon molar mass into N factor. Beta, N factor of silver is plus 1. Sorry, 1, not plus 1. Let us say 1. Why? Because charge on Ag plus is plus 1. Take its magnitude. You may say N factor is 1. What is gram equivalent of H2? It is mole into N factor. N factor of H2 is 2. Beta, N factor of H2 is 2. See, to liberate 1 mole of H2, 2 mole of electron are needed. To liberate 1 mole of H2, 2 mole of electron are needed. That's why n factor of H2 is 2. So we can solve it to get the answer. Is it clear, beta? All of you should note one point. What is that point? Note, n factor of H2 is 2, n factor of O2 is 4. How can we say n factor of O2 is 4? Beta, to liberate 1 mole of O2, how many mole of electron are exchanged? 4. That's why n factor is 4. Now let us come to another section. Another section is galvanic cells or voltaic cells. Galvanic cell or voltaic cell. What are galvanic cells? Beta, they convert chemical energy of a spontaneous reaction into electrical energy. They convert chemical energy of a spontaneous chemical reaction into electrical energy. Chemical energy of a spontaneous chemical reaction into electrical energy. All of you should note one point. Beta, in electrolytic cell we carry out non-spontaneous reactions by providing electricity. They take place only as long as we continue to provide electricity. As soon as we stop providing electrical energy, or as soon as we stop supplying electric current there, the reaction will stop. Now we can say, in galvanic cell, cathode is positive, reduction take place. Anode is negative, oxidation takes place. Beta, the very first type of problem we get here is about oxidizing agent and reducing agent. That means we have to compare oxidizing and reducing power. Let us check how can we compare. Like the question is, we are given a reaction of this type. FeCN6 4 negative converts to FeCN6. Beta, its E naught is minus 0.35. Now another is Fe2 converts to Fe3 plus electron. Its E naught is minus 0.77. Now we are required to find out which is strongest oxidizing and strongest reducing agent. We are required to find this. How can we find this? Beta, first of all see one thing. We can say reducing power is proportional to E naught OP. The one having more E naught OP will get oxidized easily, and if it get oxidized easily, then it will reduce others easily. So the one having more E naught OP will get oxidized easily and it will reduce others easily. Now oxidizing power, this is proportional to E naught RP. More is E naught RP, more is tendency to get reduced. Beta, E naught RP means standard reduction potential. more is E naught Rp, more is tendency to get reduced, and the one who gets reduced easily will oxidize other easily. Now this is first point. Second point, beta, this is undergoing oxidation. If this is undergoing oxidation, then this must be reducing agent. This is reducing agent. Reducing agent. This is also reducing agent. Now you can see, if we look at backward of this reaction, then in backward of this reaction Fe3 positive is getting reduced. If it is getting reduced, then we can say it is acting as oxidizing agent. Oxidizing agent. This is also oxidizing agent. Why? Because it is undergoing reduction, that means it will it is undergoing reduction, that means it will oxidize other. So what is point? What is important point here? All of you listen very carefully. Oxidizing agent and electron are written on one side, reducing agent is written on another side. Oxidizing agent and electron are written on one side, reducing agent on other side. Beta, when we have to find the strongest reducing agent, then we have to select between the two. When we have to find out the strongest oxidizing agent, then we have to select between the two. Is it clear? What is this? Is it E naught Rp or is it E naught OP? Beta, OP. Why? Because it is written along with oxidation reaction. If E naught is written along with oxidation reaction, then it is E naught OP. If it is written with reduction reaction, then it is E naught Rp. So it is OP. It is also OP. So can you see, oxidation potential of this is more. This value is mathematically more than this value. So oxidation potential of this is more. That's why we can say its reducing power is more. So which one is the strongest reducing agent? Strongest reducing agent, it is FeCN6 4 negative. This is strongest reducing agent. Now which one is strongest oxidizing agent? Beta, for oxidizing agent we have to compare E naught Rp. Now E naught Rp, that means beta, it's E naught Rp. Its E naught Rp is plus 0.77. Its E naught Rp is plus 0.35. That means whose E naught Rp is more? Its E naught Rp is more, plus 0.77. Therefore we can say the strongest oxidizing agent is, it is Fe3. Is it clear? Beta, all of you note it down. Till then let me check your doubts. Beta, very good. All of you are actively participating in the discussion. Very good, beta. Keep participating. Now let us come to the next point. What is next point? Beta, next point is question based on free energy and EMF of cell. That means delta G naught minus NF E naught cell. First, we can say delta G is equal to minus NF E cell. Now, question on this. Beta, first question on this is, suppose we are given reaction of this type. Reaction of this type. Its delta G is given to you. Its delta G is given to you. Let us suppose it is 960 kilojoule per mole. 960 kilojoule per mole. You have to find EMF required to reduce Al2O3 to Al. You have to find out EMF. How can you find out? Beta, you just have to use this formula. Now, how can we find out N here? How can we find out N? Beta, here we have Al plus 3, and this is converting to Al. Is it clear? Now, how much Al do we have here? It is 4 by 3. 4 by 3. Is it clear? Now, what is moles of electron exchange? 4 by 3 into 3, it is 4. This is moles of electron exchange. Now put this N in this equation. So we can say delta G is minus NF E cell. So we can say delta G is 960 kilojoule minus NF. F is 96500 E cell. We can find out EMF of this cell. Or you can say EMF required to reduce Al2O3. Now let us come to another question. Second question is, beta, all of you should note one thing. What is that thing? Delta G is an extensive property. Free energy is an extensive property, depends on amount, while electrode potential, this is, we can say it is intensive property. It is independent of amount. Say for example, like Cu2 plus, its E naught is plus 0.34. Now its delta G naught is minus 2 into F into E naught. If we multiply this equation with 2, then we can say E naught still remains the same. But delta G naught now becomes minus 4 into F into this. Is it clear? Now there is another question. What is that question? Question is, it is Cu2 plus converts to Cu plus converts to Cu. Here we have 0.15, here we have 0.50, and we have to find out this. Now how can we find this? Beta, first of all, let us write down the equation. Equation is this one. First equation is this one. Is it clear? What is second equation? Second equation is this one. This is second equation. Its E naught is, let us say, E1 naught. Its E naught is, let us say, E2 naught. What is required here? Required is Cu2 plus 2 electron converts to Cu. This is required. And E3 naught. Beta, how can we reach to this reaction from these two? Definitely we have to add them. We have to add them to reach to this reaction. Now you should note one point. Whenever two half reactions, half reaction means either reduction or oxidation. Whenever two half reactions are added to give a third half reaction, in that case E naughts cannot be added. Whenever two half reactions are added to give third half reaction, then E naughts cannot be added. E naughts cannot be added. But delta G naught can be added. Why? Because delta G naught is thermodynamic property and it adds when reactions are added. But electrode potentials are not thermodynamic functions. They may not be added. So what is the point? When we add these two, their delta G naught are also added. Beta, free energy is a thermodynamic function. That means when chemical reactions are added, it is also added. But electrode potentials are not thermodynamic functions. They may not be added on adding reactions. So we can add these two. Therefore minus N3F E3 naught minus N1F E1 naught plus minus N2F E2 naught. Let us divide both sides with N3 minus N3F. Is it clear? Now why we have said that whenever two half reactions are added to give a third half reaction, then E naughts cannot be added. Why we have said that? Beta, because in this situation N1, N2, N3 all are not equal. Here you see N1 is 1, N2 is 2, N3 is 2. Since N1, N2, N3 are not equal in question, therefore E3 naught is not equal to E1 naught plus E2 naught. Now let us put the values here. E3 naught is N1 is 1, E1 naught is 0.15, N2 is 1, E2 naught is 0.50. This was 0.15, this was 0.50. Now divide this with N3. What is N3? It is 2. N3 is 2. And this comes out to be 0.325. This is answer. Is it clear? Beta, if we have subtracted these two reactions, then here we have minus in the formula. On adding plus, on subtracting minus. Can you do a question based on this? Can you do a question based on this? This is minus 0.0306. E naught is you have to find out this. Find this. All of you attempt this question, beta. So how can we do this question? Beta, first of all, let us write down the reactions corresponding to them. Is it clear? Its E naught is. Let us do one thing. Instead of 0.0306, let us take 0.036. Why I am saying so? So that calculation will become little bit easier. So let me make a change. So as to simplify the calculation, otherwise nothing else. Now we can say for second equation, is it clear? What is equation required? Equation required is beta, now notice two half reactions are subtracted. Two half reactions are subtracted to give a third half reaction. Remember, this is a half reaction. Whenever two half reactions are added or subtracted to give a third half reaction, then E naughts cannot be added and subtracted. So here we can see we have subtracted them. Therefore, what is the formula now? E3 naught is N1 E1 naught minus N2 E2 naught upon N3. Is it clear? Or you may reach to this formula by free energy. Delta G3 naught is equal to delta G1 naught minus delta G2 naught. What is N1 here? N1 is 3. What is E1 naught? It is minus 0.036. Now, what is N2? What is N2? 2. E2 naught minus 0.44. N1 E1 naught minus N2 E2 naught upon N3. N3 is 1. We can solve it to get the answer. Is it clear, beta? Now let us see one more thing. What is that point? Effect of concentration on EMF of cell. On EMF of cell. For this we need Nernst equation. Nernst equation. What is this equation? This equation is E cell equals to E naught cell minus 2.303 RT upon NF log Q. This is the equation. Beta, Q involves concentration or partial pressures. So we can say this equation denotes dependence of EMF on concentration and partial pressure. This also involves temperature. On changing temperature, this term will change, therefore EMF will also change. This involves E naught cell. Beta, when the nature of electrode changes, E naught cell will change. When the nature of two half cell will change, E naught cell will change. That's why E cell will also change. So what is the point? EMF of cell depends on nature of electrode, temperature, concentration or pressures. Now at 298 Kelvin we may write this as E cell equals to E naught cell minus 0.0591 upon N log of Q. Log of Q. Is it clear, beta? Now let us do a simple question on it. What is that question? Question is, we are given a cell. We are given a cell of this type. we are given this cell, we are given E naughts also, we are given E naughts also. We have to find out EMF of cell. Find EMF of cell at 298 Kelvin. EMF of cell at 298 Kelvin. We have to find this. How can we find this? Beta, can you attempt this question? So try to attempt this question. Till then, let me check your doubts. So let us see how can we do this question. Beta, let me tell you one thing. These questions like this one and the previous one. What was the previous question? This was the previous question. Beta, these questions are based on Latimer diagram. Latimer diagram. Latimer diagram. What is Latimer diagram? Latimer diagram of a chemical element is summary of its electrode potential data. That means, can you see? Here we are basically giving the summary of electrode potential data of an element. Like when Fe converts from +3 to iron, then its electrode potential is this one. Like when it converts from +2 to iron, then its electrode potential is this one, and so on. So it is summary of electrode potential data of an element. Summary of electrode potential data of an element. And questions are frequently asked on this topic in your examination. And these two questions which I have written, these are actually past year questions. This one and this one. So let us see. Let us see this question. Beta, first of all, let us try to interpret cell diagram. Anode is written on the left and cathode is written on the right. This is cathode. Two parallel vertical line denotes salt bridge. Salt bridge. Different phases are separated by vertical line. Separate different phases. Different phases in contact. In contact. Is it clear? Now, whether we write cathode or whether we write anode half cell, always write reactant first, then product. That means here this is reactant, this is product. Here this is reactant, this is product. Always reactant first, product second. Reactant first, product second. Reactant first, product second. So let us write equation at anode. At anode we can say chromium Is it clear? Reactant first, product second. Chromium converting to chromium plus 3. Beta, at anode oxidation takes place. At cathode, Fe plus 2 is reduced to Fe. Now, to find out net reaction, we must have to equate the number of mole of electron exchange. Multiply this with 2, multiply this with 3, add these. Add these. Is it clear? Now let us write down its Q. Q. It is chromium plus 3 raised to power 2, Fe plus 2 raised to power 3. Let us put concentrations here. Concentration of chromium is 0.1, it is 0.01. It is 0.1 raised to power 2, 0.01 raised to power 3. It comes out to be 10 to the power 4. Is it clear? Q. Now, what is E naught cell? E naught cell is, it is E naught Rp of cathode minus E naught Rp of anode. E naught Rp of cathode minus E naught Rp of anode. Cathode is this one, anode is this one. So, Rp of cathode is minus 0.42. Rp of anode is minus 0.72. And this comes out to be 0.30 volt. Is it clear? This is E naught cell. Once we get these values, we can easily calculate E cell. E cell is equal to E naught cell minus 0.0591 upon N. What is value of N here? N is 6. Mole of electron exchange is 6. N is 6. Log Q. Q is 10 to the power 4. Beta, we can solve it to get answer. Is it clear to all of you? Now let us come to, beta, this question is very important, and such type of questions are frequently asked in the examination. Now let us come to another question. Question is determination of equilibrium constant from Nernst equation. Beta, when we will say equilibrium is attained in cell, when cell stops sending current, when cell is completely discharged, then we say equilibrium is attained in cell. So we can say when cell is discharged, completely, when cell is discharged completely, then equilibrium is established, said to be established. At equilibrium, beta, at equilibrium, E cell is 0. E cell is 0. Or you may say delta G is 0. At equilibrium, E cell or delta G is 0. And Q is equal to K. Q is equal to K. When we put this in the Nernst equation, we will get, when we put this in Nernst equation, we will get 0 equals to E naught cell minus 0.0591 upon N log K. From this, can we say log K equals to N into E naught cell upon 0.0591. This is log K. So this is formula related to equilibrium constant. Let us do a simple question on this. Simple question. Suppose we are given a cell of this type. Suppose we are given a cell of this type. Its EMF, better let me write it down. I hope you might not be able to see this. At 298 Kelvin, we can say EMF of cell is 0.2905 volt. Find equilibrium constant of this cell reaction. You have to find out this. Now, for determining equilibrium constant, we need E0 cell, and E0 cell is not given in the question. How can we determine? That means this information must be given to determine E0 cell. So let us try to find out E0 cell from this information. How can we? Beta, in anode, this is anode, this is it, this is cathode. In anode, we can say zinc is converting to Zn2 plus. That means oxidation takes place at anode. In cathode, we can say Fe plus 2 is reduced to Fe. When we add these two equations, then we get Zn solid plus Fe2 converts to Zn plus 2 plus Fe. Is it clear? Now what we can say? Beta, here Q will come out to be concentration of Fe plus 2 upon, concentration of Zn plus 2 upon Fe plus 2. This is Q. Zn2 plus upon Fe2 plus. Concentration of Zn2 plus is 0.01. Fe2 plus is 0.001. Comes out to be 10. Is it clear? Q. Now let us apply Nernst equation. E cell is 0.2905. E cell, it is equal to E0 cell minus 0.0591 upon 2 log of Q, that means log 10. Now from this we can say E0 cell is equal to 0.2905 plus log 10 is 1, and let us see what this will give on dividing. 0.02955. Is it clear? Now this comes out to be this comes out to be 5 0 0 2 3. Is it clear? E0 cell comes out to be 0.32. Now once we get E0 cell, we can easily calculate log K. Log K is N. What is N here? N is 2. N is 2. 2 moles of electron exchange into E0 cell 0.32 divide this with 0.0591. Beta, if we are required to write this in power of 10, beta, here base of this log is 10. Base of this log is 10. Then we can say equilibrium constant is 10 to the power 2 into 0.32 divided by 0.0591. Remember, log to the base a of b is c. Then we can say a to the power c is equal to b. We have used this one. Is it clear, beta? Compare these two. You will get to know how we have written this. Now, let us come to one more problem. Let us come to one more question. All of you note it down, beta. Till then, let me check your doubts. If you have any, let me check. Note it down, beta. Yes, my soldiers are constantly participating in the discussion and they are sending the correct answers. Ashish, very well done, beta. You have given the correct answer to this question. Very well done. Now let us come to, and the previous question that was based on Nernst equation, many of you have given the correct answer to that question. Very well done, beta. All of you. Very good. Now let us come to next question. Next question is, suppose we have a cell of this type. We have a cell of this type. Beta, we have to tell whether its reaction is spontaneous or non-spontaneous. Reaction is spontaneous or not. We have to tell. Here all of you notice one thing. Electrode on both sides is same. Electrode on both sides is same. The two half cell contains identical electrodes. Here also we have hydrogen electrode. Here also we have hydrogen electrode. This is hydrogen electrode. That means the half cell, you can say the electrode in the two half cell is same. So such type of cells are called as concentration cells. Such type of cells are called as concentration cell. This is concentration cell. What is concentration cell? Concentration cell is a cell in which electrode in both half cells is same. Half cells is same, but differ in concentration of species involved. Concentration of species involved. Now, how can we write down its reaction? Beta, remember, for concentration cell, E0 cell is 0. This is 0 for concentration cell. How can we say? Beta, if both half cell are same, then we can say E0 cell is E0 Rp of cathode minus E0 Rp of anode. And both these E0 Rp are identical, therefore E0 cell will come out to be 0. Now, what is equation of this? Anode. At anode, oxidation will take place. Is it clear? At cathode, reduction will take place. Let us add these two. Beta, since pressure of H2 is same on both sides, therefore we can cancel out H2. But we cannot cancel out H plus. Why? Because concentration of H plus is not same on both sides. So it is 2H plus in cathode, 2H plus in anode. Now let us apply Nernst equation. When we apply Nernst equation to this, then E cell is equal to E naught cell minus 0.0591 upon N. What is N here? 2 moles of electron exchange 2. Now log of. Let us write down its Q. What is Q? Concentration of H positive in anode raised to power 2. Concentration of H positive in cathode raised to power 2. Let us take this 2 out of this log sign. Out of this log, so we can say this comes out to be log of H positive in anode upon H positive in cathode. Is it clear? Beta, what is H positive in anode? H positive in anode is 10 to the power minus 2. Is it clear? pH 2. That means 10 to the power minus 2. What is H positive in cathode? H positive in cathode is 10 to the power minus 3. So this comes out to be minus 0.0591. It is log 10. That means it comes out to be negative. Beta, if E cell comes out to be negative, then we can say reaction is non-spontaneous. If E cell is negative or delta G is positive, then reaction is non-spontaneous. If E cell is positive, or you can say delta G is negative, then spontaneous. So beta, this is non-spontaneous. Is it clear? So let us stop today's discussion at this point only, beta. You have to do one thing. What you can do? Beta, if someone is having more number of doubts, then try to send these doubts on doubts platform so that we can cover as many doubts as possible in the given time period. First of all, first thing, we are basically trying to save some time in the doubt session. We are basically trying to save some time in the doubt session tomorrow, so that we can practice some more questions on electrochemistry tomorrow. So that's why I am saying that if someone is having more number of doubts, then he or she can post his or her doubt on doubts platform, so that some of his or some of her doubts will be taken earlier, so that we can save some time from doubt session, and we can practice some more question on electrochemistry tomorrow. So is it clear to all of you, beta? Let us meet tomorrow. Take care all of you, beta. Let us meet tomorrow.